Hey YouTube, welcome back. Today we have this problem, problem number 22, generate parentheses. Problem is medium and it has been asked, whoa, it has been asked a lot. The problem says given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. For example, if we have the input 3, we could add it, we should return this output of the all parentheses that we can do with 3. And as you can see, if we have 3, that means we should have 3 open and closing brackets, so we have 6 characters in each string. And it's important to know that we should have 2 multiplied by n, where n will be 3 here for each one, because we will use this in the future. In the previous video, to solve this problem, we did this by brute force, and as we saw before, we had limit exceeded. Today we could just use like a backtracking with like create a backtracking function and start to call this function over and over in a recursive way. So the way we can do it, let me try to do in the code first. So let's create an answer array, and this answer array, we store all of our values in it. Okay. And we will try to create a current string, like a current, and this one will represent each string that we try to push to the answer array. And this one will be also a new array, okay. And what I'm thinking about that, it's let's do something. We return the answer here, and I will create a backtracking function here. Let's create a function. I'll call it backtracking, and I will give it like, maybe we have like the left count. Let's call it left, and let's call it right, and let's have like the current, and you know what, I will put this one here because I might use all the variables here. So when you have left and right, and I'll try to call this function with the first string where left and right is 0. Backtracking, let's call it the backtracking here with 0 and with 0 and 0. And let's start here and see how we can do it. So first I will try to see like if the current dot length equals 2 multiplied by n, that means we have a parentheses, a valid parentheses. So what we do with the answer dot push the current dot join, yep, and maybe we could just return nothing. We return nothing. So we end the function here because it's a recursive function. So we try to put our base case, and the base case here, it will be if the current dot length equals 2 multiplied by n, because I can see here the maximum length for each string is to be 2 multiplied by n, which is 3. So you see all of them is 6. So I'll try here to put the left side and the right side. So I'll say if left count smaller than n, because I expect the left count, the left should be equals to n, and the right should be equals to n as well. If the left smaller than n, what I will do, I will say cur dot push. I will push to it the closing, and I will call the backtracking again here for the left side. So I will put left plus 1 and I'll put right. So in this we try to calculate the do the left side, and I will do, it's important to take the string, the first one again, the pop, the last one. Okay, so I will do the same with the right. Let's do it here, and I guess we will be done. And I will try to like, I guess it will take time to describe all of that, because recursive is always hard to describe. So just be aware with me if you don't understand anything. It's normal. Do not worry. And the right plus 1. And I guess that we are done. Let me run and make sure that it's working. It didn't work at all expected, and it did had let's see why. I have the current string, the answer, new array, the backtracking. I have left and right. I say if the current string dot length equals 2 multiplied by n, answer dot push, the current dot join. Okay, read and return null. If left smaller than n, current dot push, and I call backtracking again, left plus 1 and right, and I'll do current dot pop, and if if left bigger than right. Sorry for that. Yeah, okay, so let's just try to describe here. Okay. Let's see here. So right now we I guess let's submit and see if it will work or not. Okay, and it's bit good. Okay, it's not bad. So first let's talk about what we're doing here. So first we create an empty list called answer to store the valid parentheses combination. Okay, after that we call and also we store the current. The current is to it's represent each string. And we call the backtracking function with empty string builder 0 and we initialize left and right count as 0 and the given n. Okay, we say here in the backtracking function, we check if the length of the current string here equals to 2 multiplied by n. If it is, we add the current string to the answer list and return it as it means as we have formed a complete valid combination. Let's talk about these two things right now. So if the left count is less than n, it means we can add an opening parentheses, and we do this one. So we append and we add opening parentheses to the current string. We recursively call the backtracking with an incremented left count and then remove the last character from the current string, as you can see. If the left count is greater than the right count, it means we can add a closing parentheses. So we do that, and we remove the last one. But let's try to understand. For example, you can also do slice, but let's see that why we basically remove the last element. Like why we do that? Because maybe some of you will try to ask this one, like why. You can use also array.slice if you want. So So like when we add the opening parentheses, okay, to the current string, we do so to explore one possible, and we need to undo this operation before moving on the next possibility. This essential for backtracking. Similarly, when we add closing parentheses to the current string, we do it to explore another possibility, and we also need to backtrack by removing this character before trying another combination. So by making Bob, we just making sure that we remove it before trying any other new thing. So yeah, so that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you will never miss a video, and see you in future problem.